Hello. So let's get started looking at something amazing that dropped today. Effectively, Gemini 2.0 has launched. And why is that a big deal? So before we had a lot of releases by Google, and honestly, they were pretty lackluster. They were impressive in their own scale, but they had issues. Let's not even get started on that. And then just was not as impressive for a company that's literally pioneered search, right? There was something wrong with it. But today that does change, and I'm going to tell you why. So if you look at there, expanding Gemini 2.0, and they're showing you like effectively the 4 different models that they have launched, right? And everyone's talking a lot about Pro, but I also want to highlight something very important. I think the flash light and flash thinking are amazing on their own. And Pro is, of course, the most impressive because it is their largest model, but Flash and Flashlight are incredible. And I'll tell you why. But before that, here's like a summary that shows what's happening. The Flash thinking also is not available to try right now. It's experimental, but you can still try it on the not YouTube Studio, their Google AI Studio. Of course, all of these models are freely available for you to try. You can, of course, just go to Google AI Studio, just open up a free account, and then you can try any of their models right here, effectively. Here they're showing you how each of these are. And in fact, over here, it gives you the exact pricing. And that leads me to the first point, and I think the strongest point. It's not the best model that they've launched in the world, right? There's clearly O1 beats Gemini 2.0 Pro by a good margin. What is amazing, and you're gonna see that very soon, is the pricing. And these numbers sort of might not make sense to someone who does not use these for like actual work, outside of just using it on their website. I'll talk about why these prices are amazing, and for that I really want to jump into this website. This website is amazing. I would suggest anyone who wants to sort of get into AI and sort of learn about where everything is happening and what's happening over here to go into this website. This has all the high quality data that you would ever need. And it literally has comparisons of every new model that's being released. And that really gives you an idea of where everyone stands. So I'm just going to literally talk about what's happening here. So as you can see, this is the quality effectively, right? O1 is the highest with our accuracy. And so 90, it has a score of 90. And then O3 Mini, it's pretty darn good. I had a video about O3 Mini last time, so if you want to watch it, go ahead. But it's impressive for how closely it matches with O1. O1 being a much more expensive model. But yeah, as you can see, the Gemini Pro is over here at 85 and Gemini 2 Flash is 83. So clearly not the best models because R1 is still over there at the top. What's impressive is this chart over here. The pricing is incredible. If you look at O1, that's dollars, by the way. That's $26 per million tokens versus Gemini 2.0 Flash. That's $0.2. 20 cents, $26. It's like 150 times more expensive than Gemini 2 Flash, or 150 times cheaper. That is incredible if you think about it. And for how accurate it is, it's very close in performance. Like, yes, it's 7% less performance in terms of accuracy, but I'm telling you, it's really still good. 83 is not a bad number. 83 is amazing. And like this, it's so bad. This skews this graph so bad because everything else is over here and then O1 is at the top. So like you can see, and it says per million tokens. So a million tokens is a lot. And what a token effectively is a way of representing, is a unit of sort of describing an input for or output effectively for these LLMs. A token is approximately or a word is approximately 1.5 tokens. That's the average. It's pretty rough, but that's kind of it. It's basically breaking up words, and and the way you break them is you sort of break them into these tokens, and that's what this is basically. But what's important. I really want to go a little deeper into how good Gemini 2.0 is, because their Flash variant is amazing. So as you can see, this is a quality versus price graph, and so effectively this is the quality index that goes up, 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 and over here the price goes up, up, up. However, I love this four quadrant sort of design because this effectively tells you gives you a very brief like overview of which models are really good, because are the most attractive. This green box is effectively where you want to be in relation to everyone else, because the lower you go in on the x-axis, the lower the price is, and the higher you go is the better your accuracy is. So you really want to be up in this quadrant effectively. So this top left quadrant is where you want to be. And if you see how cheap Gemini is over here, V3, this is DeepSeek V3, it's over here. O3 Mini is over here. O3 Mini is actually really good. That's the one model that they released, was that O1 after O1, that was actually pretty impressive, which I also cover in a previous video. And R1 is over here. Still a little bit more expensive, but it's amazing. It's R1, as you know, as you have seen, it is much better than or actually wait, no matter, they're actually the same. They are the same performance. My bad, my bad. That's what it is. But yeah, you're gonna see all the other models. Claude is here. Haiku. This is Haiku. It's not even Sonnet. Sonnet is way over here. This is the best model that Claude has. Oh, and yeah, it's called Claude Sonnet, and it's nowhere near the sort of cost to performance benefits that you're gonna get over here. Similarly, quality versus output speed. Speed is basically how many tokens per second they can generate or how fast these are. It's opposite over here. You want to be in this quadrant over here because the higher your speed and the higher your quality, that's better. So you always want to be on this top right quadrant. And effectively, yes. So that's sort of interesting. But it's just so good to see these the price be so low. And the other impressive thing is context window, honestly. Context window for Gemini is 1 million, by the way. And Claude Sonnet is 200K, O3 Mini is also 200K, but most of them are over here, down here, 128,000 tokens. So just to be sort of give you an idea, 1 million tokens is roughly 80,000 lines of code. That's a huge number, by the way. That's an entire code base. Usually, most of the tests that people show you are about what are they about? They take you basically into this one specific project, like an idea, like, oh, here's this, I want to do this, I want to do that. Give me a sphere inside which the balls bounce or something like that. That's how they do it. However, that's not a big project. You can literally have it in like maybe at best case scenario, like, or worst case scenario, 7,000 like lines of code. And that'll relatively fit into 128,000 tokens, because 200 tokens is roughly 1/5. So you're going to assume 1/5 of 80,000. That's somewhere about like 15,000 lines of code, right? 15, 20,000. 20 is about 1/4. So we can go a little lower. 15,000 tokens. What's incredible is 1 million. And Gemini 2 Pro has 2 million. It's not here, but it's 2 million tokens. So just double how much 80,000 lines, 160,000 lines of code. So that's incredible that we have such like context windows. Context windows are effectively how wide or how much data you can sort of give the model and then sort of query or ask about it effectively. So now we don't even need to deal with issues like RAG. Like, wow, these models are getting so good, you really don't need to. RAG is like a RAG, or RAG is a way for you to extract huge information from huge databases and sort of then push them into the model efficiently, because usually you can't like take an entire code base and dump it into like Claude or GPT-4, for example, and then ask it questions. It just can't, because it won't fit in its context window. And that's largely what it is. But now with like these models having 1 million, like these numbers are incredible. We won't need that system anymore. They'll become obsolete, because and that's funny, because any business that was building itself to become a really good RAG application, it's gone. We won't need them anymore. But yeah, and just look at this. This pricing is sort of incredible. Like, I think we have the cheapest ones over here, but look at how expensive these were before. Like, you won't see that on your end because you're only paying for what, $20 a month for one of these subscriptions. But as a developer, you are looking at these per million tokens, because that's what you are effectively paying each time someone uses your product that is leveraging one of these models. And if you see Claude Sonnet, it's one of the best models out here, but it's $3 for every 1 million input and $15 for every 1 million output. So you sort of combine them to get a rough estimate. So it's like $18 together is insanely expensive. $18 per million tokens. That's bad. That's one of the worst. For being one of the best quality models, this is they really need to work on this. Similarly, O1 Mini has been like pretty expensive. I haven't so and I think I didn't show it to you here, but if I put O1 here, it's skew O1 the O1 model itself into this graph now, you're gonna see it skews everything. Did you see that? Did you just see that? It is crazy, like how it's O1 is over here. It's so bad because this is the uh, ideally this is the worst place to be in, but look at the cost. It's $26. $26. Ah, who's gonna pay for that? So this is amazing, right? And let's see, where's O1? O1 is, yeah, see, O1 quality and output speed, everything else is good. It's the pricing that's the problem. Look how it skews it. Ah, god dang it. O1 is again, yeah, it's pretty good over here. Context window. O1 is over here. Even O1 has an here. But look at the price. Yeah, this price is insane for developers. Like I was talking about, Claude Sonnet. This is the 18 that we were looking at, and this is $75. $75 for a million tokens is crazy. Compared to that, that's 7 cents. That's 7 cents. And then that's 30 cents. For 40 cents total, you get something amazing. And this is Flash. Flash is very close in performance to O1. That is 150 cents. 50 cents versus $75 for the same amount of thing. You see how amazing that is? Finally, I am so happy Google has done something, because it's been so long. Like, it was due. It was long due for something good to actually happen. And boy, have they delivered. It's really good. Like, that's the whole point of it. Look at this. The pricing. It just pushes. O1 is just every time it's so such an outlier. Like, they really need to just, the O3s are going to be impressive, but that's true though. But yeah. That's what it is. And part of that, I think, the reason that they were able to even do this is because of TPUs, their new hardware. Like, Google is the one company that can do it, right? They're the one company that is so massive. They can work with their hardware. They can work with their the software. They can work with the models. They have the data. They have everything from the start to finish. They're the ones who could effectively outbeat everyone, and they weren't for such a long time. Finally, something good's come out, and it's because of, I think, one of the main reasons is these TPUs. TPUs are tensor processing units. They're the next level. So we have CPUs, are what you have on your computer, pretty much central processing units. Then we have GPU, graphical processing units. These GPUs are what most models use to sort of train and run inference. You can run inference on a CPU as well, but they're much slower. So you really want to use GPUs for that. But now TPUs are the next level, tensor cores. Basically, they have tensor cores in them. And tensor cores are higher dimensional matrices, effectively. That's so a matrix effectively is 2 by 2. So a list is just so here, okay, here's a little crash course on what matrices and tensors are. So a number is a single number, right? So that's what is called a scalar. 1, 2, 3, 4. They individually, they're scalars. But now if you put them in a list, basically 1, 2, 3, 4, 5, that entity is called a list or a vector. So it's a vector. Now, when you take one list and then you combine lists, so it's like a 2D array. So an array of lists basically is now a matrix, effectively. And so now it's basically has 2 dimensions. So it's a matrix. And a vector has 1 dimension, and a scalar has 0 dimensions, effectively. And so now when you have the matrix, right, it's like this. You can take it to the next dimension, right? 3D. So you have a layer of sort of a square like this, right? A matrix that has like numbers in it, and then you effectively stack more of them. It's like a stack of books basically. And so that would be a tensor. That's the first tensor you're gonna see because you're stacking matrices on top of each other. You can now extend that even more into 4 dimensions. We can't visualize that, but imagine you were able to do that. And so you keep going into higher and higher dimensions, and those are tensors effectively. And so these cores effectively can manipulate tensors really well. That's the whole idea, and that's why they can process a huge amount of data. And effectively, why they were able to train their Gemini 2 on this trillium TPUs, and that's pretty much why they got some really fast results. And also running inference. Our inference is basically, so training is when you train the model, and when you run it and use it, that's called inference effectively, and that is also 3 times faster. And they're also very energy efficient, so the cost goes down. And so I'm pretty certain they're offering these models on these TPUs to us, and that's pretty much why we're receiving so much cost benefits, especially when you consider all of this. But yeah, in general, that's pretty much what I wanted to even just introduce. I'm actually happy again. Like, I know I keep talking about so much AI stuff, but there's so much happening, and it's such a good thing for the world because at the end of the day, I really wish that every AI, much like how search is accessible to everyone, I really want AI to be accessible to everyone, and that's it's really exciting to see that we're getting there pretty fast. And if anything, things are going to get even better. There's more competition. Google now finally show their A game. We're going to have more companies sort of fighting against them, and competition is amazing. And that's kind of what we want at the end of the day, because users benefit, developers benefit, everyone benefits from this. And the world is going to be an exciting place because of this. So, yeah, thanks for watching.